Hi, I'm Luke. In this diagnostic module, I'll take you through the steps on how to diagnose a heated control circuit on a 4-wire narrowband oxygen sensor. I'll show you some different methods to use when diagnosing, and we'll show you the readings you can get with these faults. On this vehicle, I have an engine light on the dash with a fault code P0050, oxygen sensor heated control circuit, bank 2, sensor 1. This is not the only O2 heater circuit that can be logged. As you can see here, there are many more. This procedure can be used to diagnose all these DTCs. I asked the customer, when did they notice a light on the dash? Information from the customer can be valuable when diagnosing a fault. It was while driving on a highway. Before we proceed with the fault code, always start by checking the basics, by checking your battery voltage. With the ignition off, check for any burnt, chafed, broken or corroded wires, and unplug the connector at the oxygen sensor and check for corrosion on the plug ends as well. Then reconnect. If available, check the freeze frame data. On this vehicle, it isn't available, so let's have a look at the live data. I've selected bank 1 and 2 heated oxygen sensors and compared the readings of both sensors. As you can see, bank 1 sensor 1 is around 94 ohms and bank 2 sensor 1 is 0 ohms. This vehicle's data for the heated O2 sensors does not read the value in volts. I can verify that there's an issue with the heater control circuit on bank 2 sensor 1. We need to test the circuit. Let's take a look at the diagram. Before we test the circuit, let's look at how it works. Voltage comes from the battery through the engine relay control side to the engine control unit where it is grounded by a low side driver. With the ignition on, the ECU activates the relay, closing the contacts, supplying voltage to both oxygen sensors via a fuse. Pin 2 of each oxygen sensor is connected to a low side driver, which is pulse width modulated. Now that we know how the circuit works, we can move on to testing the circuit. We don't need to worry about testing the signal and low reference voltages of the O2 sensor, as we are only dealing with a heater circuit fault. Now we need to disconnect the O2 sensor. This is so we can test the harness side. I'll switch the ignition on and set the multimeter to volts DC. It's a good idea to set your multimeter to 2 decimal places using the range button. This will give you a quicker reading. I'll start by checking the voltage between pin 1 on the harness side of the O2 sensor, as well as connecting up to the negative battery terminal. Make sure you use the correct test connectors when carrying out these tests. As you can see, there is no voltage. I should have 12 volts. Going back to the diagram, this is ignition voltage, so we know now this part of the circuit is not working. Check the fuse. Physically pull it out and inspect it. And if you're unsure, use a resistance check. It's okay. Check for 12 volts at one side of the fuse. I have 12 volts. This indicates that I have 12 volts from the battery to the fuse. Looking at the diagram, if the fuse was blown, you would have DTCs for both heated oxygen sensors due to both pin 1s being in parallel. We can safely say there is no issue with the engine relay or with the voltage supply from the battery to the fuse. This is because I only have a fault with bank 2 sensor 1 heated oxygen sensor and not the other sensor, and the readings from the live data indicate only one heated sensor is functioning. From this point, there must be a break in the wire. This is because I have 0 volts at pin 1 at the O2 sensor on the harness side and 12 volts at the fuse. We also know that the fault can only be between the splice and pin 1 on the affected sensor. The choice is to repair or replace the harness. I was lucky it was easy to find, So I repaired this section of the harness. With the fuse installed, I'll check for 12 volts at pin 1 again. Now that I have 12 volts, I need to reconnect the O2 sensor. Then recheck for faults. Using the scan tool, clear the fault memory. Once this is done, recheck for faults. Reset field trims and carry out the correct drive cycle for your vehicle. In this case, the sensor is continuously monitored, so all I have to do is switch the ignition off and on again. Then check the readiness monitor for the oxygen sensors. For most current model vehicles, be sure to initialise the component after the repair, even if you didn't replace it. This is usually found in the special functions or teaching process menus of your scan tool. We still have issues. The faults come back, but this time, no engine light. It's now an elimination process. Let's go back to the diagram. I've now determined that the voltage supply from the battery and fuse down to pin 1 of the O2 sensor harness, bank 2 sensor 1, has 12 volts. After I repaired the broken wire, I can now move on. From here, we need to test the heater control wire, which is pin 2 at the harness side of the O2 sensor. And it's controlled by a pulse width modulated low side driver and ground within the ECU. With the O2 sensor disconnected and the ignition on, I'll check pin 2 for a ground. This is done by connecting a multimeter set to DC between the positive terminal and pin 2 of the oxygen sensor on the harness side. Don't expect to see 12 volts at this point, as this is a pulse width modulated ground. I have 0 volts. This means I've either got an open circuit or a shorter voltage. To check for a shorter voltage, I'll leave pin 2 still connected to the multimeter and swap from the battery positive to the negative. As you can see, I still have 0 volts, no shorter voltage. On the diagram, if there was voltage at pin 2, this would be a shorter voltage. From here, we can see that there's another connector. This will be our next test point. Using a workshop manual, I found that the connector is behind the glove box. Because I'm in the vehicle, I can use pin 16 at the DLC, as this is battery voltage. I'll connect the other lead to the heater control wire on the harness side of the connector that's behind the glove box and check for a ground. I still have 0 volts. From here, I need to back probe the ECU connector with the connector still plugged into the ECU at the appropriate pin. Be careful when back probing ECU wires, as these are WeatherTex connectors. Again, I've got no ground. The only possible fault now could be the ECU connector or the ECU itself. I need to check the terminal tension at the ECU connector using the appropriate tool. You should feel a bit of drag. It's okay, so it must be the module. Now let's remove it. If we take a look inside the module, where the connector plugs onto, the pin is bent flat, probably from a poorly installed connector. Extreme care must be used when installing these multi-pin module connectors. Let's go back to the diagram. If this wasn't the case, the problem would be a faulty low side driver within the ECU, or the ground within the ECU itself. This is conclusive evidence that the ECU is faulty. I'll replace it. Always follow the correct procedures when programming control units. Now that I've replaced and programmed the ECU, I've cleared the faults and rechecked for codes. I now have no faults. And if you look at the live data again, you can see the readings for both sensors are now working. If you have an oscilloscope, this is what a faulty pattern would look like. The vertical axis is voltage, and you can see that the pattern is not completely grounding to 0 volts. And if it was open circuit, the pattern would be a flatline signal at a steady 12 volts. Our normal heated control signal will look like this. You can see that the ECU is completely grounding the signal to 0 volts and is in a square wave pattern. Once again, carry out the correct drive cycle for your vehicle and recheck the readiness monitors once you have cleared the faults, and carry out the teaching processes on your vehicle if it has this function available. This concludes our training module on O2 sensor heater circuit diagnostics. We had a look at how we can trace faults that cause the same DTC on 2 different occasions. Understanding how the circuit works helps with diagnosis. And remember, keeping up to date with technology is essential in today's automotive industry. Thanks for watching, and bye for now.